All right, welcome back. So in this video, we are going to be going through some simple examples on trig functions and their inverse functions. And we commonly see the phrase SOHCAHTOA to help us out in remembering the ratios between the sine, cosine, and tangent trigonometry functions. So let's go through all three. Here we go. So the first example we're going to go through is the sine, or the SOH, right? So it's always the sine of the angle is equal to the opposite over hypotenuse. So let's go through two examples, one on how to use the sine operation and then the inverse operation. So for the first example, it's going to be sine of 42, because that's our angle, is now equal to the opposite over the hypotenuse, where the opposite is 4, hypotenuse is x, and now we just want to rearrange and get that x all by itself. So we get that x is equal to 4 divided by the sine of 42. We simply take our calculator, punch that in, so we have 4 divided by the sine of 42, and we get about 5.98. So we get x is about 5.98. Now we may have a situation where we're not given the angle and we want to find the angle. So we're still going to write it out the same way. Sine of our angle, which is y, is going to be equal to the opposite over hypotenuse. So it's going to be equal to 6 over 13. And just like any other operation, we do have inverses. So if we want to negate the sine operation on the left-hand side, we have to take its inverse. So we're going to get that y is equal to sine inverse of 6 over 13. Let me scroll here. Boop. So now we simply plug it into our calculator. We hit second sine. That way we're seeing sine inverse, or sine to the -1, of 6 divided by 13. And we get about 27.49. So we get y is about 27.49 degrees. Sweet, nice. Let's keep it going. So here's the cosine. We also hear the ka. So it's the cosine of the angle is equal to the adjacent side over the hypotenuse. So let's go through two examples here. On the left-hand side, we're given the angle. We're trying to find a side length. So we're going to write cosine of the angle, which is 51, is equal to the adjacent, which is x, over the hypotenuse of 12. We want to rearrange and get that x all by itself. So we get that x is equal to 12 times the cosine of 51. So we just plug it into our calculator, just like it shows, 12 cosine of 51, and we get about 7.55. So we get about 7.55. On the right-hand side, we're given the two side lengths, but we need to find the angle, so we're going to have to use the inverse here. So we're going to write out, just like we would, cosine of our angle, which is y, is equal to the ratio of the adjacent side over hypotenuse, so it's 3 over 10. And now we need to negate the cosine operation by doing the inverse. So it's going to be cosine inverse of 3 over 10 is equal to y. Let me scroll. We plug it into our calculators, and we get that y is about, remember this isn't exact, but it's a good estimation, cosine inverse of 3 over 10, and we get it's about 72.54 degrees. Sweet, sweet, sweet. That's 2 out of 3. Here we go. Last one, the tangent, okay, or the TOA. It's the tan of our angle is equal to the ratio of the opposite side over the adjacent side. So let's go through two examples. Over on the left-hand side, we're given the angle, but we're trying to find one side length. So we're going to write tan of our angle, 15, is equal to the ratio of the opposite over adjacent. So the opposite is x, adjacent is 8. We want to rearrange to get x all by itself. So we get x is equal to 8 times the tangent value of 15. And we get, when we plug it in, 8 tangent 15, we get about 2.14. Get about 2.14. One more. Here we go. So we have, in the example on the right-hand side in red, we're given the two side lengths, but we need to find the value. So we're still going to write it as we normally would. So it's the tangent of our angle, but our angle right now is y, is equal to the opposite over adjacent. So it's equal to 12 over 17. And just like we had before, we need to take the inverse of tangent to negate that tangent operation, or that tangent function, I should say. So it's tan inverse of now 12 over 17 is going to be equal to y. We plug it into our calculator. So we hit tan inverse of 12 over 17. And we get that y is about 35.22 degrees. All right, great job, everyone. Again, that was just going through some simple trig function examples. There are more that are complex, but this is going to be a great foundation for us to move forward. If you have any questions, please feel free to reach out. Keep up the great work, folks.